Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Dig into those concepts, reiterate them. Alright, so moving on. 11.2 Mitigating VLAN Attacks. So we've already discussed VLAN hopping attacks can be launched in a few different ways. One of the big ones is a end device being able to use either DTP or some other function to get a trunk port connected to that switch. That way it can be part of the native VLAN on that interface. You can also introduce a rogue switch by, again, allowing trunking to take place. Or you can do double tagging or double encapsulation of a frame to double tag a VLAN. So how do we actually mitigate them? Very straightforward, very simple. Do not allow for auto trunking. You hard code switch ports to access mode or to a trunk mode. You don't allow for negotiation. You hard code the appropriate VLANs. So again, the big takeaway is disable DTP, don't allow for auto trunking, make sure to actually set your ports correctly. And again, looking at the native VLANs, modifying it from the default VLAN. So let's talk about how we mitigate DHCP-based attacks. The goal of DHCP starvation is basically to gobble up all of the spare addresses in that pool, basically creating a denial of service on that service. If a person can't get on the network because there's no addresses available, well, that's a denial of service attack. So recall that DHCP starvation attacks can be very effectively mitigated by using basic things like port security, because the gobblers use unique MAC addresses for each of the DHCP requests. However, mitigating those spoofing attacks require more protection. So with this, we can actually use some of the tools that are built in. One thing that Cisco allows for is basically what's called DHCP snooping and trusted ports. This is one thing that's normally not turned on for whatever reason. So essentially, DHCP spoofing attacks, again, using DHCP snooping on a trusted port will mitigate those types of attacks. So snooping filters DHCP messages and it rate limits the traffic on untrusted ports. So that means if something is coming up on an access port and it's just continuously requesting addresses, it can rate limit how many requests can be sent on that port, unless it is trusted. So devices under administrative controls like switches, routers, servers, you can declare as trusted. Trusted interfaces like trunks and server ports must be explicitly configured as trusted. You can set all other ports outside of that to be untrusted. And again, you can rate limit how many requests are being asked on those ports. So a DHCP table is built that will include source MAC addresses of devices on an untrusted port and the addresses assigned by the DHCP server. We already know that's how it functions. You have a MAC address and it maps to an IP address. Therefore, this table can be called the DHCP snooping binding table. MAC address that is known and the address that is assigned. So how do we actually implement DHCP snooping? Well, first of all, we enable it globally. We issue the IP DHCP snooping command. On the trusted ports, navigate to the port. You can do IP DHCP snooping trust, and that on that interface will allow it to be trusted. On untrusted interfaces, you can also then limit the amount of limit the rate of packets per second for DHCP. And you do that by issuing an IP DHCP snooping limit rate space the PPS on that interface. And again, you can also do this per VLAN by issuing the IP DHCP snooping VLAN configuration, and that will be done globally as well. So here is the configuration for snooping per interface, for a range of interfaces, and for VLANs. This is trusted, this is untrusted, and we're setting a rate limit, and this is setting it up via our VLANs. And here you can see that this is going to be the trusted port, and this will be the untrusted port. That way, things that are coming this way will be trusted, things that are coming this way will be rate limit. So, how can we verify? You can do a show IP DHCP snooping, and that is how we can verify the bindings. Moving forward, we have our ARP attacks. Typical ARP attacks is basically a threat actor can send an unsolicited ARP reply to other hosts when the subnet to try to get their addresses. How do we mitigate this? Well, we can do dynamic ARP inspection, DAI, and this requires DHCP snooping and helps prevent other types of ARP-based attacks. Basically, what ends up happening is it allows not replying to invalid or gratuitous ARP replies to other ports in the same VLAN. It will intercept ARP requests and replies on untrusted ports. It will verify intercepted packets for a valid IP to MAC address binding. It will drop and log ARP replies coming from invalid to prevent poisoning. It will also do error disabling the interface if configured DAA numbers of the ARP packets are exceeded. Now, the disabling that interface is outside the scope of the CCNA. That's just one of the things that can happen. So how do we configure this? Same way that we did the DHCP snooping, we do it globally and then on each selected VLAN, and then we can also enable dynamic ARP inspection on each VLAN, and then lastly we configure trusted interfaces for snooping and ARP inspection. On the untrusted ports here and here, we can actually do our ARP inspection. On the trusted port, it's going to allow those to come in. So, how do we look at that? How do we configure that? Well, we set our trusted port, we set the trusts, and we turn them on per VLAN. And on the non-trusted ports, it will actually do snooping and inspection. Dynamic ARP inspection configuration checks the destination and the MAC addresses. So it's going to look at both the MAC and IP addresses. It can do based off of destination, source, or IP. So if it's doing it based off the destination MAC, it'll check the destination MAC in the header against the target MAC address in the ARP body. Source MAC, it'll check the source MAC address in the header based off the ARP body. And lastly, it will check the IP of the ARP body for invalid or unexpected IP addresses, including addresses such as multicast addresses, quad zeros or quad 255s, or IP addresses outside the normal range. Normally it's looking for class A, B, C, sometimes D, but any E or F range are thrown out. So again, other configuration, we can do like validation. We can do validate source, validate destination, validate IP, and we do that at the global configuration by issuing an IP ARP inspection validate source, destination, or IP. So it just kind of depends on how we want to do our filtering. Lastly, we're going to talk about mitigating STP-based attacks. We already know about PortFast and PPDU guard. Well, the nice thing is PortFast on edge ports will automatically turn them on, and they should be done on edge devices. PortFast immediately brings up a port to a forwarding state, but it bypasses listening and learning states. This allows for user in-device access. BPDU guard basically guards immediate error disable on a port that receives a BPDU guard when it shouldn't be. So example, PortFast should not be enabled in between switches. It should only be enabled on edge or in-device access based ports. So if a switch gets plugged into those ports and a BPDU actually comes through, error disable, and that port's turned off because it was configured to only access end devices and another switch was plugged into it. How do we actually set this up? What we can do is navigate to the interface. We can set spanning tree port fast default, and that will allow us to actually set it globally to any of the access ports. We can also set it per interface by doing a spanning tree port fast. And again, it will even tell you it needs to only be configured on ports that are connected to a single host. Again, spanning tree port fast default globally turns it on to all access ports, or you can do it based per interface with a spanning tree port fast command. And you can verify by doing a show spanning tree summary, or by going to the interface and looking at the details. How do you configure BPDU guard? Very straightforward. Just like we set up spanning tree port fast, we'll do the same thing but with PBDU guard. You can navigate to the interface, spanning tree, BPDU guard, and enable it. Or you can do it globally by issuing the spanning tree port fast BPDU guard and set it to default, and you can verify with a show spanning tree summary just to verify. Questions, concerns, please reach out. Thank you.